Welcome back. This is Mrs. Rewrite with Algebra 1 Honors. Today's lesson is 3.3, Writing Functions. Alright, so let's look what we got here. Performing operations with functions. Given f of x equals 3x minus 1 and g of x equals negative 2x plus 2, find h of x equals f of x plus g of x. So you're doing f of x plus g of x. So you're combining these. So we have our 3x minus 1 plus negative 2x plus 2. We need to combine like terms. So we have our 3x's minus our 2x's, and we have our negative 1 plus our 2. 3x minus 2x is 1x or x. Negative 1 plus 2 is 1. So we're going to get that our h of x equals x plus 1. If we're given f of x is x plus 5 and g of x is 4x minus 2, and we're trying to find f of x minus g of x. So we have f of x minus g of x. We need to distribute this negative. So we have, I don't like what they're doing. For me, I would distribute the negative first. So I have x plus 5 minus 4x plus 2. You guys with me? Now put the x's together. So you have x plus negative 4x, or x minus 4x, plus 5 plus 2. This is how I would do it. So you have negative 3x plus 7. Make sense? Now you're multiplying them. So h of x equals f of x, which is 3, times g of x, which is 1/3 x minus 2. You're going to need to distribute. Three times 1/3 x is x. 3 times negative 2 is negative 6. So x minus 6. Oh, they don't want the coordinates. They just want the negative 1. Okay, so negative 1, 0, 1, 2, 3. We're just literally plugging in the answers that they solved. The table shows the values of the sum of f of x plus g of x for several values of x using the functions f of x and g of x from part A. Use the rule that you found for h of x in part A to complete the third column of the table. What do you notice? They're going up 1 each time, right? For any x, values of f of x plus g of x and h of x are equal. So these are these answers. Well, yeah, that's how you get them, right? A student wrote the rule for h of x in part A as 5x plus 1. After letting x equal 0 and observing that f of 0 plus g of 0 equals negative 1 plus 2, which equals 1, and h of 0 equals 1, the student concluded that the rule must be correct. Describe what is incorrect about the student's reasoning and describe what the student should have done to check the rule for h of x. So, the values of f of x plus g of x and h of x should be equal to all values of x, not just one value of x. The student should have checked more than one value of x. Right? You have to go and check multiple things to make sure that it works in all situations. For the initial year of soccer camp, 44 girls and 56 boys enrolled. Each year thereafter, 5 more girls and 8 more boys enrolled in the camp. Let t be the time in years since camp opened. Write a rule for the following functions. So we have g of t, the number of girls enrolled as a function of time, b of t, the number of boys enrolled as a function of time, and then we have t of t, the total enrollment as a function of time. For the function g of t, the initial value is, so g of t, our girls. What is our initial value for the girls? What do you guys think? Initial value for the girls? 44. And the rate of change is, what's it going up by? 5. So g of t is going to be 5 per year plus the 44 they started with. For boys, initial value for boys. 56 boys were enrolled, right? And their rate of change, they're going up how many each year? 8. So they're going to be 8 per year plus the 56 they started at. So the total enrollment is the sum of the functions g of t and b of t. So we need to add these together. So we need to add 5t plus 44 plus 8t plus 56. 5t plus 8t, 13t, 44 plus 56, 100, right? So 13t plus 100 is your t of t. Use unit analysis to show the rule for g of t makes sense. So in the rule, 5t plus 44, the unit associated with 5 is girls per year. The unit associated with t is years. And the unit associated with 44 is girls. So you have girls over years times years plus girls equals girls plus girls, which equals girls. So the rule makes sense. So just to make more sense of this, years have to be diagonal to cancel out. So you'd have girls plus girls, which is girls, right? As long as the years, as long as what you're trying to get rid of cancels out, they have to be diagonal from each other, then they're gone. And so your units are in girls, and so it makes sense. All right, so, wow, this is long. All right, multiplying linear models. Multiplying linear models. For the soccer camp in the previous example, the cost per child per year was $200. Let t be the time in years since camp opened. Write a rule for each of the following functions. C of t, the cost per child of camp as a function of time. The cost per child of camp as a function of time. R of t, the revenue generated by the total enrollment as a function of time, t. Okay, so for the function c of t, the initial value is what? Cost per child, initially, 200. And the rate of change is? What's the rate of change? 0. So C of t is going to be $200. The revenue generated by the total enrollment is the product of the cost function and the total enrollment function, T of t, which was found in the previous example. So R of t equals C of t times T of t. That's the general rule. Substitute the rules for C of t and T of t. So C of t, what did we get for C of t? 200. And T of t? 13t plus 100, remember? On the previous page. So when we FOIL this out, what is 200 times 13t? 2600t. And 200 times 100, 20,000. Explain why C of t is a constant function. There is no change in the cost of the camp from year to year. Use unit analysis to explain why you multiply the cost function, C of t, and the enrollment function, T of t, to get the revenue function, R of t. That's a mouthful, right? The unit associated with C of t is dollars per child. And the unit associated with T of t is children. So you're going to get dollars per child times children equals dollars. Why? Because the children cancel each other out. Which is the unit that you want for the revenue function. What is the initial revenue for the camp, and what is the annual rate of change in revenue? So the initial revenue is $20,000, right? The initial revenue. And their rate of change is $2,600 per year. The camp's organizer had initial expenses of $18,000, which increased each year by $2,500. Write a rule for the expenses, the E of t. Then write a rule for profit, P of t, based on that. Okay, so your E of t. Your expenses. Well, you have 2,500 t plus 18,000, right? Your expenses are 2,500 per year plus the 18,000 initial, right? And then a rule for profit. So the profit is the difference between revenue and expenses. So your revenue, right here, revenue, minus expenses. Right? Distribute your negative. 2,600 t plus 20,000 minus 2,500 t minus 18,000. 20,000 minus 18,000 is 2,000. 2,600 minus 2,500 is 100 t plus 2,000. Does that make sense? Recall that inverse operations are operations that undo each other. Similarly, the inverse of a function is another function that undoes everything the original function does. So, the inverse, find the inverse f of x equals 2x plus 1 using inverse operations. All right, list the operations of the function and perform the values x in order for the function to perform them. As we'll illustrate the next steps using x equals 3. So we're using x equals 3. All right. So we are going to, okay, so x multiplied by 2 plus 1, add 1, right? So you have 3, if we're plugging in a 3. 2 times 3 is 6, and then 6 plus 1 is 7, right? They're just saying 2 times 3 plus 1. They're just writing it weird. List the inverse operations in reverse order. Illustrate the steps using x equals 7. All right, so if we're doing x equals 7, we're going to subtract by 1 and then divide by 2. We're going to subtract 1 and divide by 2, right? So 7 minus 1 is 6, and 6 divided by 2 is 3. So we're just working backwards, right? Write a rule for the function g of x that performs the inverse operations in reverse order. Check your answer by using the g of 7. All right, so we have so x minus 1 divided by 2, 7 minus 1 divided by 2, 7 minus 1 is 6, 6 divided by 2 is 3. The first table at the right shows some input-output pairs of the function f. The input of f are listed as inputs for the function g in the second table. Complete the second table. All right, so if we're plugging in -3. So -3 minus 1 is -4. -4 divided by 2 is -2. 1. 1 minus 1 is 0. 0 divided by 2 is 0. 5. 5 minus 1 is 4. 4 divided by 2 is 2. G of B equals your A, right? Is it reasonable to describe f as a function of the inverse g? Yes. F undoes what g does, just as g undoes what f does. Okay, they're opposites. They're going to undo each other. To find the rule for the inverse of a linear function f, let y equals f of x, and solve for x in terms of y. Whatever sequence of operations f performs on x to obtain y, the process of solving for x will introduce the inverse function in the reverse order. We now have a function g where g of y equals x. Since x is commonly used as a function input value and y as its output variable, as the final step, switch x and y to obtain g of x equals y. Finding the inverse by solving y equals f of x for x. Find the inverse y equals 1/2 x minus 1. All right, so let y equal f of x. Solve for x in terms of y. Okay, so y equals 1/2 x minus 1, right? We're going to add 1 to both sides, so y plus 1 equals 1/2 x, right? Then we are going to multiply by 2 on both sides. And we would have 2 times y plus 1 equals x. Distribute. 2y plus 2 equals x. Okay, so switch the x and y and then write the rule as the inverse function of g. So we would have 2x plus 2 equals y. The inverse f of x is g of x equals 2x plus 2. Okay, so to me, this sounds all kinds of confusing, right? Because they did it opposite of how I normally do it. So what I always do is if you're solving for the inverse, all you do is just, like, this is y equals 1/2 x minus 1. To do the inverse, you switch your x and your y. So do x equals 1/2 y minus 1 and solve for the new y. X plus 1 equals 1/2 y, and then you would multiply by 2. 2x plus 2 equals y. Done. Make sense? Switch your x and your y, solve for the new y. And that is the inverse function. Switch the x and the y, solve for the new y. Inverse function. So for inverse, switch the x and y and solve for the new y. Make sense? Are you guys okay on that? Do you understand what to do? All right, so it says find f of 4, then use the value as the input x for g of x. What output would you get, and why is this expected? I honestly think this is a great place to stop because all you really need to know is for the inverse, switch the x and y, solve for the new y, and you will be fine. So your homework tonight is on 137 and 138. So I hope you guys enjoyed your lesson on 3-3. I know it was a little bit long. So have a great night. Like and subscribe.